In this lesson, we're going to focus on graphing parent functions for the rational functions. So here's the rational parent function for y equals 1 over x. You might also see this notation as f of x 1 over x. So I have a t-chart here, and I'm going to go ahead and just set it up. So you have your x values, your domain, your y values is your range, your output, and you're going to evaluate it. So think about just starting with the number 1, and I evaluate that. 1 over 1 equals 1, and substitute 2 in. 1 over 2 is 2. Now let's choose 0. If I substitute 0 into the function or the relation, I get what we call undefined. So what we're going to have is an asymptote, a vertical asymptote where the function is undefined. Now let's choose negative 1. 1 over negative 1 is negative 1, and then substitute 2 in. 1 over negative 2 is negative 2. All right, so that's just a little bit of order pairs here. So I'm just going to go ahead and stretch out my x and y axes. So 1, 2, 3, 4. 1, 2, 3, 4. Same thing here. All right, let's graph a few order pairs. So one order pair is over 1 and up 1. The next one is over 2. Oops, that should be up 1/2. So go ahead and fix that, please. Up 1/2. All right, just fix that green. So over 2, up 1/2. All right, imagine if I substituted 3 in. When I substitute 3 in, I get 1/3. So over 3, I get up 1/3. If I substitute 4 in, I'm going to get 1/4. Notice, as I keep going along this x-axis, my number's going to get smaller and smaller and smaller and smaller, but it's never going to touch. Now, I'm going to go ahead and write an arrow there. As I get closer and closer to x equaling 0, approaching 0, the number's going to get bigger and bigger and bigger and bigger. All right, so what I'm going to have is an asymptote on the x-axis. We call that asymptote y equals 0. We also have another asymptote, a vertical asymptote, at x equals 0. All right, we do still have to graph a couple more points here. Remember, there's an asymptote at 0, makes it undefined. And now we're going to go ahead and graph left 1, down 1, and then left 2, down 1/2. Again, now if we go ahead and try to plug in negative 3, we're going to get negative 1/3. Plug in negative 4, we're going to get negative 1/4. So it's going to go ahead and have that same shape as up above in that first corner there, and that's what the graph looks like. So we do have those asymptotes we talked about. The vertical asymptote is at x equals 0. The horizontal asymptote is at y equals 0. What type of numbers can you plug in? You can plug any number in for x, except x cannot be 0, because that makes it undefined. The range of values, what type of numbers are you getting out? You're getting every number out as an output, except the vertical axis. So you have a restriction on the y of y cannot be 0. All right, go on to the reciprocal squared parent function. This also can be written as a function, f of x equals 1 over x squared. Let's go ahead and set up a t-chart again. So we have our x-axis, our x values, and then our y values, 1 over x squared. We'll substitute some numbers in. I'm going to just substitute 1 in. So 1 over 1 squared is 1. 1 over 2 squared, excuse me, I have a little bit of cold here. All right, so I have 1 here, 2 here. So 1 over 2 squared is 1/4. If I substitute 0 in, 1 over 0 squared makes it undefined. So again, just like the last problem, we have an asymptote when x equals 0. All right, so let's go ahead and plug in negative 1 and negative 2 and see what happens. 1 over negative 1 all squared. Well, negative 1 times negative 1 is 1. 1 divided by 1 is 1. All right, last one, 1 over negative 2 squared. We're going to get positive 1/4. Okay, so I'm going to stretch this out again. All right, we do have an asymptote at x equals 0. So there's that vertical asymptote. I better change color here. There's that vertical asymptote when x equals 0. So x cannot be 0. So I'm going to vertical asymptote at x equals 0. All right, graph a few points here. So one of the points is over 1 up 1. Next one over 2 up 1/4. Imagine if we substitute 3 in. 1 over 3 squared would be 1/9. So as we approach this, it's going to continue on and then rising up. All right, graphing -1, up 1. -2, up 1/4. If we substitute -3 in, we're going to get 1/9. It's going to go ahead and here is our graph approaching. It's going to have another asymptote on the horizontal axis at y equals 0. So there's another asymptote. All right. So pretty similar to the last problem in its curves. The asymptotes are still the same. The domain, every number works except for x cannot be 0. And then the range. Look at the range, it's a little bit different than the reciprocal function. It's everything greater than 0 above this line right in here, okay? So that's how you can graph the reciprocal and the reciprocal squared parent functions.